class, so if you are watching this, that means I have been otherwise delayed in France, possibly. So luckily I pre-recorded a session for class on July 7th, and I will walk you step by step through what we're learning today. It's another standalone lesson, meaning it's not going to show up on a test anywhere, but it's just more useful ways to use Excel to look at data. So today we're talking about pivot tables and some formula logic. In our Moodle page, you'll open up the assignment titled Lesson 5, Pivot Table. We will go through that together. You'll have just a little bit to do on your own, and then turn that in. So let's go ahead. So once you've got that open, I've got two exercise tabs for you: sales data and components. And we're going to start with the sales data. We're going to start with learning some Excel argument logic, and particularly if statements and if-then logic. So these are arguments that we're going to create, saying we're looking for one thing and we want Excel to return a certain value or not. So for example, we want to return the unit cost for each line item. I guess we should go through the data that we're looking at. We've got sales, we've got the order date, the region, east, central, or west. We've got the name of the sales representative. We've got the item. Our items are pencil, binder, pen, desk, and pen set. In our data set, we've got the number of units sold, at what cost they sold it, and the total of that purchase. So you can see that on January 1st in the East region, the rep with the last name Parent sold pencils, 74 boxes, I assume, of pencils, at a cost of $1.99 per box. So an extended price of $147.26. So that's our raw data. We go down to row 87 here with all of our data. If I want to write a statement saying, if my top line is a pencil, tell me what the catalog cost is. Return the catalog cost for each line item sold. By the time you get this, that will be updated on your spreadsheet. So I'm going to tell Excel, if cell D2, my first row, if the item is a pencil, tell me what that catalog cost is. The difference between this catalog cost and we have unit cost, for the most part it's the same. You can see pencil, $1.99, $1.99. But we also have an example here of a binder with a unit cost of $8.99 and a catalog cost of $19.99. So in this case, we're kind of comparing what was the unit cost, what did it actually sell for, versus what do we have it listed for in our product catalog. And so these may be because of discounts. Maybe this is an old customer that their prices have been grandfathered in, or they get specific unit discounts or whatever. It's business. There's always wheeling and dealing done. And so for some reason we gave them a unit cost of $8.99 instead of $19.99. That's a pretty good discount. So I'm telling Excel in that first row, if it's a pencil, give me the catalog cost. So and it's written here as an example, equals if. So if, and then we're gonna create our argument, our logical test, and then if that's true, give me this value, or if that logical test is false, give me this value. So our argument is if D2 is a pencil. So if D2 equals the word pencil, the other thing you could do, you could just write pencil. I put it in quotes because that tells Excel that it's text. You can either write out pencil, or you can reference the cell that it is. So if D2 equals I2, and even if it's text, Excel will compare that. It has to be exactly the same. So if D2 is a pencil, then give me the catalog cost, which is J2. If it's not a pencil, just put a 0 in there for me. That's fine. And we get $1.99 because D2 is in fact a pencil. It's given me the catalog cost of pencil. We could say that same thing. Now let's look at a line that's not a pencil. So if D3 equals pencil, if it's a pencil, D4, sorry, not D3. So if D4 says pencil, then give me the catalog cost, otherwise give me a 0. I get a 0. That little hash mark is a 0 because I have it formatted. It's just the way it's formatted. I can nest if statements together, which makes a really crazy looking string of arguments, but it ultimately all makes sense. It's a lot of commas and parentheses. I put the example here, but let's go ahead and write it out. So I'm going to say if D2 is a pencil, give me the catalog cost for pencil. But if it's a binder, give me the catalog cost for binder. But if it's a pen, give me the catalog cost for pen. And if it's none of those, then just give me a 0. So let's start that. We start the same way. If D2 is a pencil, and we'll go ahead and just write it out as pencil. So if D2 is a pencil, then give me the catalog cost for pencil. If it's not a pencil, then I want you to check to see if it's a binder. So then if D2 equals binder, then give me the catalog cost for binder, which is J3. If it's not a pencil and it's not a binder, then I want you to check if it is a pen. So is D2 a pen? If it is a pen, give me the catalog cost for pen. If it's not a pencil, it's not a binder, it's not a pen, just give me a 0. I don't care about it anymore. Now we have to close. See how we've got 1, 2, 3 open parentheses? We've got to close each of those open parentheses to have a full valid argument. We can copy that down and we can take a look at our what we get here. But we're just going to have to lock down particular cells. We always want to reference the correct catalog cost. That cell stays the same regardless of where we copy, across or forward or down or up, wherever. So we want to lock down all of the catalog cost cells. So that'll be locking down J2, J3, and J4. Once I've locked those down, I can copy down and we can take a look at our results. D2 is a pencil, so our results are the catalog cost of pencil. D3 is a pencil, and so our result is the catalog cost of a pencil. D4 is a binder, so our result is the catalog cost of a binder. D5 is a binder, and so our result is the catalog cost of a binder. It's not, as you can see, we charged a different unit cost, but we returned the catalog cost. D6 is a pen set. So it's not a pencil, it's not a binder, it's not a pen, it's a pen set. And so we said if it's not a pencil, binder, or pen, give me a 0, so I got a 0. So that's an if-then statement. If this is true, give me this value. If this is false, give me this value. It's really handy. I really like writing if statements. They're kind of fun once you get into them and figure out the logic. If you do hard code stuff in, like pen, binder, pencil, or you're comparing exact matches and you find you're not getting the results you want, it typically means that these things don't match, and that could be because there's a weird thing in it. And so you can see if I accidentally had fat fingered a comma in there, I get a 0 because it's not pencil. It doesn't match the word pencil. So that's the first thing to check if you're not getting the results that you want. So it kind of looks like a mess, but it makes sense once you know each piece of it, and people will be super impressed with your ability to write if-then statements, nested if-then statements. You're pretty fancy. So now we can do a sum if. So we have one criteria. It shows up a bunch of times, and we want to get a summary total of a specific piece that goes along with that. So for example, we want to return total sales for each sales rep, and we'll just start with 1. These are all of our salespeople, and so we'll start with Jones in this example. We want to return total sales for the sales rep named Jones. So we could go through and say Jones, well, that equals this plus this plus this, and all the way down the line, but you can see that's going to get really cumbersome to do for every single sales rep. So we can create a sum if argument. I'll create the first one over here, and then we'll do it for all of the salespeople. So say sum if, give me a sum if. The range, so we can grab all of our reps. We can do it one of two ways. We can grab all the reps in our data set, or if we think that the number of rows is going to change over time with new data sets, new months, I can actually grab the whole column just by clicking on column C, and it'll just say C through C. Column C in our data set is always going to be sales rep, but the number of rows, as we add information, the number of rows might change. So now we don't have to update our array in the formula. It will always grab column C. So if anywhere in column C you see the word Jones, which is I9 here, which is our sales rep, and we'll lock that down in just a second. If you get Jones, then I want you to give me their total sales, and that's going to be in column G, And again, I'll just grab the whole column because as we add rows, again, we want to make sure we capture all of their sales. So we added up every single line item for Jones. So let's write that again. We'll lock down the cell we need to lock down, and then we'll copy that down and look at every single sales rep. So this is a sum if. So if in sales rep you find the name Jones, then add up their total sales. And since we just chose the columns, we can go ahead and copy that down. We don't need to lock anything down because C and G are going to stay what they are. So now we can see we've got totals by sales rep. So for Kivel, this is their total, so on and so forth. Howard had the least amount of sales. Maybe they're new. And we can see, just glancing through, yeah, we see some pretty small numbers for Howard. They don't show up much, so makes sense. So that's a sum if. Give me a total if this criteria is met. We could do a count if. Maybe we want to know the number of times things happened. So count how many times a sale was made in each region. So how many times, we've got 3 regions, Central, East, and West. How many times do you see the word Central in column B? That's what our count if statement is saying. So equals count if. Count if anywhere in column B you see the word Central. 48 times Central shows up. So let's rewrite this in our region and copy down for the other 3 regions. So count if in column B, and again, we could just highlight the whole range, like in the example here, say B2 through B87, but I'm just going to grab the entire column so that I never have to update it. So count if in column B, you find the word Central 48 times, and now I can bring that down. 26 times for East and 12 times for West. These are just the number of times that word appears in this column. So we're just counting each complete sales transaction by region. I think it's nice to know the formulas to do that. An alternative way, and what we'll spend the rest of the time on, is talking about pivot tables. And this is another way to categorize and summarize our data, and in fact can replace a lot of these logic arguments in specific instances. There are times to use the formula, there are times to use pivot tables, just kind of depends on what you're doing. So we are going to create some different pivot tables here, and then we're going to do it again on our components sheet. Let's say we want to replicate this total sales by rep. We did it up here with our sum if formula. And now instead we want to create a pivot table that will do that for us, summarize sales by rep. We just come up to Insert, and at the top, I'm on Excel for Mac, so at this point some things are going to look a little bit different for you, so you'll just have to play around with it a little bit, but overall it should be pretty close. So on the Insert tab, you're going to find a pivot table. It's probably over in the left-hand corner, hopefully. Just click on Pivot Table, and you are going to need to select your data range. So we are just going to click that all of our sales data range. And even if the pivot table that you're not creating right now isn't going to include all of these columns, that's okay. Still select that data range, because the great thing about a pivot table is you can easily swap out columns and rows. And so just put everything in your data range and then sort it out in your criteria. And then we are going to, you could create a whole new worksheet. It could be on its own worksheet. We're just going to put it right in this existing worksheet, and we're just clicking one cell. You don't need to select a whole range. Just click one cell where you want the upper left-hand corner to be, except it just overwrote I was in the wrong thing here. Okay, start over. And you do want these labels. So my data range, my existing sheet, click into it. And so I'm just putting the top left-hand corner of my pivot table in cell L41. I'll click OK, and right now we have a whole lot of nothing, but that's fine. You can see it's got kind of a ghost pivot table. And then over to the right-hand side, you should have some pivot table fields and options. Yours might look a little different than mine, but in general, it's all the same idea. You're going to have all your field names. You see these are the columns that we have in our data table. And then you can see you've got filters, columns, rows, and values. We're going to focus on columns, rows, and values in our lesson. So the first pivot table we want to create is that total sales by rep. You can see that my rows, so going down, I want to see my sales reps. So these are the rows. If they were going across, they would be columns. So going down their rows, I want sales reps in rows. And my values are their total sales. I don't have any columns in this right now, but we'll do other pivot tables with columns. So I just drag and drop rep into rows. Oops. And you can see all my reps show up here. And now into my values, I'm going to drag and drop total. And this defaults to the sum of whatever you put in values. We'll mess around with that later, but for now we just want the sum, so that's fine. And that's it. We did exactly what we had above. We can see this puts it in alphabetical order, so that's why it looks a little bit different, but we can verify our numbers. Jones is 16,309 and Jones is 16,309. So we're getting the same total sales by rep. And then we can change these however we want. We want to still look at total sales, but instead of by rep, we want to look by region. So we put region into rows. Excel did it for me when I clicked here, but I could have dragged it there. So now I've got total sales by region. Once you're done with these, you can format the numbers to look better, put columns or dollar signs or whatever in there. So that's total sales by region. How about total sales instead of by region? How about by item? Nope, I don't want that. I want item. So here's total sales by item. What if we nest some things? Total sales by region, then item. Well, I can add region to my rows, and I actually want to do it by region, by item. So in my central region, this is my total sales for binder. In my East region, here's my total sales for binder. In my West region, here's my total sales for binder. How about average units sold by rep? So now we're done with some of the total. We're done with these guys. And now we want average units sold by rep. So we know we want rep in the rows. And the units now are going to be our values. This sums the number of units sold, but we actually want to see the average number of units per sale. So we can right click on our values and find field settings. And now instead of sum, I can just choose average and click OK. And I can see that Andrews sells an average of 45.75 units for each sale that he has recorded. We could look at average units and total sales by item. So we've got average units. Instead of rep, we are looking by item. And I want to look at total sales. And again, the default is to sum what we put into values, and so that's fine. That's what we want for total sales. So I kept my average units by item and total sales by item. So binder, average number of units bought per binder sale, I guess, is 49.57. And the summary of our total binder sales was 24,870. You could change that to the average total sales by right-clicking again, going to field settings, and saying average here. And so the average binder sale is a total of $829. Average desk sale, a total of $2,054. So it just depends on what you want to see. On your own, create a pivot table from the sales data with the criteria of your choosing. So something different than up here. There are a million possibilities. So make it crazy. Go crazy. Use several criteria. I don't have anything other than just make your own. So do that after you're done watching this recording. Or pause it and do it now. But we're going to make a whole bunch more pivot tables with some different data and look at that. So here are some components. An air compressor manufacturer purchases mechanical components from 2 different suppliers and electrical motor components from 3 different suppliers, with final assembly being carried out by 1 of 2 technicians. Following production, finished compressor units are tested to measure how much pressure they exert, measured by PSI. During the past few months, 100 compressors have been tested before shipment to customers, and the data is listed below. And how this works is this MECSUP stands for Mechanical Component Supplier. So we've got Mechanical Component Supplier 1 and Mechanical Component Supplier 2. This next column is the electrical and motor component suppliers, and we've got 3 of those, right? So we've got E1, E2, and E3. And then the third column is the technician who does the assembling. And so we've got technician 1 and technician 2 here. And so for each compressor that was tested, we've got their measured PSI. So for this first compressor that we tested, we noted that they came from mechanical supplier 1, they came from electrical supplier 1, and it was assembled by technician 1 and had an output of 400.2 psi. So that's a lot to organize. So depending on what we want to look at, we can create pivot tables to organize this for us. So which company supplied mechanical components the most, I guess? We can insert a pivot table. So go to Insert, Pivot Table. And let's look at our table range. And we'll come all the way down. And since we are, we're going to insert, we're going to keep the pivot tables that we have and insert new ones. So I'm going to copy this and just save it to my clipboard so that I can paste it when I need to. And I'm going to insert this pivot table right here at G10. Okay. So again, I have nothing. So we can just look at the count of the mechanical supplier. What did they supply? So we can make a count here. It defaulted to count because there's nothing to total for that, right? We put a qualitative variable in here. It's not a number. It's a, it's a label. So in this case, our pivot table defaults to count it. So we see that mechanical supplier 1 supplied 49 of the compressors, and supplier 2 had 51 of them. And we got a grand total of 100. That makes sense. So we just counted suppliers. We could kind of nest them. What if we count by electrical supplier, by mechanical supplier? So we could insert the pivot table. Here's where I'm going to paste that data range. And I want my pivot table to show up here, so that's good. And if we count by electrical supplier, by mechanical supplier, I'm going to put mechanical supplier in my columns, and then we need to count one of those. So we can see that the cross-section, we can see the cross-section of suppliers. How many compressors came from mechanical supplier 1 and electrical supplier 1? 16. And so on and so forth with each of them. What if we want to show the average PSI according to mechanical supplier and electrical supplier? So let's go our data range. So now we've got, what do we do over here? Electric, then mechanical as our columns. And so we could do it either way. We can still do electrical supplier as our rows, mechanical supplier as our columns, and we want average PSI now. So PSI are our values now. And that gives us our sum of PSI, which does not mean anything. So we'll go into field settings and change that to average. And we can see we've got our average PSI by electrical supplier, by mechanical supplier. And we can swap these as well if we want. We can have mechanical and electrical. rows, columns, however we want to do it. Average PSI is still what's calculated there. What if we show the average PSI by technician? We can do that. Let's insert a new pivot table. Oops. Paste my range in. And now we want average PSI by technician. Change that to average in a second. Field settings, average, okay. So by technician, here's their average PSI. We can show the standard deviation for PSI. We found the average. What about the standard deviation for PSI by technician, mechanical supplier, electrical supplier? What combo has the highest variance or the lowest variance? So now we're working in some of those other statistics that we've learned. So let's go back, insert our pivot table, paste in our range. So we want by technician, then mechanical supplier, and then let's put electrical supplier in our columns. And let's put average PSI as our values. Oh, not average PSI. Oops, sorry. Standard deviation of PSI right down here. And let's get rid of too many decimal places. So now we see, putting all of our data together, we can start to evaluate these different combinations and see what's best and what's the worst out of the bunch. And we can run numbers in a lot of different ways to try to figure out which part is maybe the cause of the largest deviation. So since we're looking at standard deviations, we find which combo has the lowest variance. That's technician 1 with mechanical supplier 1. Oh, sorry, no. We have an even lower one here, 1102. So our lowest variance is technician 2, mechanical supplier 1, electric supplier 3. What combo has the highest variance? Looks like Tech 2, mechanical supplier 1, electric supplier 1. So it's interesting that the highest and lowest variance are all with Tech 2, mechanical supplier 1, and so the only different variable in this is the electric supplier. 3 has the lowest variance and 1 has the highest variance. So do we need to look at electric supplier 1? And they do typically have the higher variance altogether. So why are their PSI numbers more prone to vary so widely? So that'd be something to look at. And we can, keep digging into these numbers to find out what's happening. So feel free to, mess around with other pivot tables for this data. But that covers everything that I wanted to show you about pivot tables. Make sure you create your own pivot table with the sales data. Or if you choose to create your own with the components or both, whatever, just create at least one more pivot table with either set of data and that will be good. And upload that on our Moodle page. And hopefully this will be my last out-of-town class lesson. I should be back and ready to go for Monday's class. But if not, who knows? Who knows what's happening? I'll get it worked out. Don't worry about it. All will be well. All right, take care, and I will see you soon.